It's a special pleasure when Hank Landsberg's with us. Hank's got some really neat gear. He has got some nice audio history from Drake Chenault. He's got all kinds of good things to share with us. And today we're going to talk about, we'll start with clean power. And Hank, we'll turn the table over to you and get started.
Okay. Well, thanks, everybody. I assume you guys can hear me okay?
Can hear you fine. And
Great.
while I'm going to mute all the microphones here just to get rid of background noise, and you can unmute yourself, I'm sure that you welcome questions
Sure.
as we go through.
Absolutely. Well, thanks for inviting me this morning. Hello to everybody. I see a few friends and a few new folks, new to me anyway. Yeah, we'll talk about clean power, specifically at transmitter sites, because that's always an issue. And then if we have time, a couple of other studio solution type things. But I wanted to let you guys know about a new version of our Powerclamp surge suppressor products that is coming down the pike here, probably be available in about 3 or 4 weeks. You're probably familiar with the Powerclamp units that we've been selling for a while, quite a while. We started in, let's see, probably the early 2000s, when the product was recommended to me by a good friend of mine, LA area engineer. Some of you may know him, Tom Koza. He had been using them for quite a few years at some of his radio stations, and they seem to work miracles at getting rid of spikes and surges and power line glitches that cause transmitters to go off the air and trip breakers and stuff like that. So to make a long story short, I ended up starting to sell the product to the broadcast industry. And then when the original owner of the company wanted to retire about 10, 12 years ago, I ended up absorbing him and kind of buying him out. So anyway, so that's where it came from and how I got into the surge suppressor business. The units that we sell most frequently for use at a transmitter site are the big ones. This is an empty shell, but you can see the physical size of the thing. It's about 1 foot tall and 8 inches across. This is the new version of this is the size of the new version, which is rated at 200,000 surge amps per phase. And they work really great. The two advantages that Powerclamp provides is that the clamping level above which spikes and surges are chopped off is very low. It's only typically 10, maybe 20 volts above the peak of the sine wave with normal voltage. So if you're on a 120 volt circuit, nothing above about 130 volts is going to get through. Anything above, well, RMS, peak value of 120 is around 166 or so. So starting at about 175 volts, nothing's going to get through above that threshold. And the other thing that these units tend to do is they tend to reduce or eliminate noise and harmonics that might be on the line. Again, just because of that really low clamping level. Well, over the last several years, as I'm sure you guys know, transmitters have gone largely solid state, and not nearly as many of them require 3-phase power, 480 volt power, because the solid state transmitters are so much more efficient. So we're seeing the installation of a lot more transmitters, especially lower power ones, that only require standard single phase 120/240. Now the thing is, these units are able to handle any voltage up to 480 volts, 3-phase. But we started selling an awful lot of these for single phase 120. And the thing is, when the PC board that goes inside here is loaded for a single phase 120 installation, the board is only about half full. There's an awful lot of empty space in here. And it didn't make a whole lot of sense to me to be selling a product that's half empty because you're paying for something that's, you know, just empty space. So I decided to see if we could kind of shrink this thing down for installations that only require 120/240 volt single phase or you know, split phase, where you've got 120 neutral, 120, or 120 ground, 120. And in a lot of cases at transmitter sites, since the unit is normally installed right at the main panel, that's where your ground and your neutral are tied together. So in that kind of an installation, you don't need a separate neutral to ground suppression circuit, because those two are tied together right there. So what we did was come up with a new version that is specific for 120 single phase, no neutral to ground suppression circuit if it's not needed. And here it is. As you can see, it's a whole lot smaller than this, but it has the same ratings. It's also, I'll open it up. This is what it looks like on the inside. It's also rated for 200,000 surge amps per phase. And by eliminating all the empty space, it makes the thing about half the size, and that translates into less money. So we haven't got the price on this figured out exactly, but I'm pretty sure it's going to come in at least 20–25% below the cost of the equivalent that used to be in this size box. So instead of costing roughly $2,300, this new one, which is identical in performance, will be probably somewhere around $1,700. So that'll save you like $600 with no reduction in performance. We also can offer the remote status option, which is simply a contact closure from a relay that trips if either of the fuses in here blow or if you lose a phase. So that is also about half the price of what it used to be in the bigger unit. So so this is a new product. It's going to be coming out probably middle to end of March, so 3–4 weeks down the road. And so it's just a good thing to know about. If you have a transmitter installation where you want really good surge protection and cleaning up harmonics and whatnot, if it's a single phase installation, 120/240, this new unit will save you a bunch of money. So that's the new product that I was going to talk about. And then also on the subject of power monitoring, let's see. Oh, we have another product that's been out for a couple of years. I'll mention it briefly in case you are not familiar with it. I don't have one in front of me, but I have a picture that I'll show you. Let's see if I can make this work. There it is. This is the inside of a thing called Power Tracker. And quite simply, it just gives you a way of monitoring your AC voltage using your transmitter remote control system. You can probably guess what's in here just by looking at it. Basically three power supplies that take the AC voltage, convert it to a low voltage DC, either 5 or 12 volts nominally. And then you take that and feed it into one of the analog channels of your transmitter remote. So once you get it all calibrated and so forth, you can figure out and keep an eye on what your incoming AC voltage is. And you can do that from the studio. As you can see, this is a 3-channel device for 3 phases. So whether you have single phase or 3-phase power, all you need is one box, one of these devices, to monitor the AC voltage of all the phases. This product is the same size as the smaller Powerclamp that I just showed you. And if you look just north of where the fuses are, you'll see a bunch of jumpers there. That's where you set the configuration for what kind of power you're monitoring, whether it's single phase, 3-phase Y, 3-phase delta, and what the normal voltage should be. So this thing can monitor any voltage 120 up through 480, single phase or 3-phase Y or 3-phase delta. So it's pretty simple. The green connector in the upper right-hand corner, that's your DC output. And so there's 3 outputs, one for each phase. You feed that into your remote control, and away you go. So this is a thing called a power tracker. So at this point, does anybody have any questions?
First of all, ask you the question about, there's one here for the power clamp. Can you protect 3 single phase lines on a 3-phase unit?
3, well, if you have 3-phase, are you talking about the surge suppressor or the power tracker?
The surge suppressor.
Okay, the new surge suppressor is for split phase, single or split. So either 120 or 2 120s that give you 480 across the outside. If you have 3-phase power coming in, then you just need a 3-phase unit, which would be the bigger one.
Okay.
The new smaller one is just for single phase.
All right. Let me ask this question now. Do you find the purity of power coming in? Where do you find the problems? Now, yes, you've got the power coming in, and then you've got the power that's coming out of the UPS boxes, and they're not even, in some cases, very clearly formed.
Yeah.
So
where's the grunge coming from?
yes.
It could be coming from a couple of places. It depends on who else is on the grid in your area. If you're at a transmitter site, like we have a couple of sites here in LA where the transmitter is in the middle of an oil field, and they've got all these oil pumping things, whatever they're called, you know, the things that go up and down. Well, those things cycle on and off all the time, and they've got these big, huge motors on them, and every time they kick on and kick off, pow, you know, you get a big old spike on the line. And if you're near that, you know, physically near that, those kind of spikes and whatever other junk other power users on the grid are feeding back into the line. They're not supposed to, but they do. That's one source of noise. I mean, if your transmitter site is not too far from a welding shop, you're going to have all kinds of stuff, because, you know, things like welders that draw arcs, anything with a big motor, like a commercial printing plant, commercial laundry, any place that uses things with big motors, even if they're air conditioning, you know, air movers and that stuff, that sort of thing. there's a lot of noise and junk that comes from other users on the grid. And the closer you are to those other users, the more stuff you're going to get. And then the other source of noise is switching power supplies that are in your facility or close by. Those things are supposed to be filtered so that all the switching transients and whatnot don't feed back into the grid. But who's to know how good they are or how well filtered they are? If they're consumer gear, those are often the worst offenders because they don't always meet the same standards that the professional gear power supplies do or are supposed to. So switching noise from switching power supplies, that's a real issue. And then, of course, like you said, you have UPSs that may or may not generate decent sine waves. The outputs of generators. Also, when generators switch online, you got a transfer switch, which, older generators don't necessarily try to sync up to incoming power, especially if the power's already gone off, then they don't know what's going on. When it switches to the generator or switches back, you can have a big fat glitch if the generator doesn't sync up to the sine wave that's coming in off the grid. So you have your choice of a lot of different things that can give you some glitchy, dirty power, in addition to, the usual lightning strikes and stuff like that. The thing about power line spikes and surges is they come from two places, or you can divide it into two general sources. One is lightning and other atmospheric stuff. And depending upon where you're physically located, lightning hits, they don't happen very often. But when they do, they're huge. The voltage spike is huge. But then you have all the sort of the man-made glitches and spikes that come from motors and welding shops and power supplies and all that other stuff. They're not nearly as high voltage-wise. They may be only a few hundred volts above normal. But those you'll get hundreds a day or hundreds an hour. And those things cause problems, especially with switching power supplies. They seem to be much more vulnerable than just your basic, linear supply that's got a transformer and diodes and capacitors. So you got stuff coming at you from all different places, and it has different characteristics as far as amplitude and how often you get it.
Well, that sounds like a very important thing to have on the power line. How often do the parts in a power clamp fail?
Hardly ever. Because of the way we design these things, our units, all the power clamp units, use two distinct circuits that react to different voltage levels. We have one circuit that is primarily MOVs, and that is there for the really big, nasty stuff, that spikes that are thousands of volts above normal. But because we set the threshold of those things high enough, those components don't feel the low-level spikes, which come much more frequently. So as a result, the MOVs don't degrade because they don't conduct unless there's a really high-level spike coming down the line. We have a secondary circuit that soaks up the lower-level stuff. And the components in that circuit are not at all really susceptible to failure from age. All of our units, we have a 5-year prorated warranty on them. And we've been selling these things for almost 20 years, at least 15 years. And I think we've shipped probably a couple thousand of them by now. And on the average, we replace a unit once every 3 or 4 years. Not very often.
That's a pretty
So,
good track record.
Yeah, the track record is really good. This product was originally designed in the late 70s by a guy who was a physicist working for the Navy. And the original customer, the original installation was Navy bombing test ranges. And the problem they had was when they would drop their bombs or whatever they did, it would shake up the AC and all their computers and stuff because of the EMP and whatever. So to make a long story short, the company came about because of this physicist guy who designed this product that would get rid of all those glitches. And there's all kinds of surge suppressor gadgets out there. The problem with many of them is if they rely only on MOVs, the problem is you have to set the MOV threshold so low that the MOV is always conducting a little bit. So it's always dissipating heat. And that means that it degrades over time because the heat vaporizes the metal oxide material in the MOV. So after 6 months or a year, the threshold begins to gradually rise from the heat, just like a resistor that goes up in value from heat. And after a year or two, so much of the MOV has evaporated or disintegrated inside. The threshold is now so high up, it's not doing anything. But by using these two different circuits, one to attack the high level stuff and a separate one to attack the low level stuff, we keep the MOV threshold high enough so they don't conduct with normal voltage. So they don't continually heat up and burn themselves out and degrade. So the clamping level stays right where it is when the unit's new. We have a lot of these things that have been in use for 15 or 20 years and they're still working. So that's where it came from, and that's why the thing is designed the way it is.
That raises two good questions. One, and Reiner wants to know, is it UL or ETL type listed?
This is a new model, so it's not yet. Whether we actually do that, it's a little up in the air. The cost of that is just exorbitant beyond belief. So I don't know. But as of right now, no, it's not.
Okay. I would imagine that in some jurisdictions that becomes important, but I don't know.
Sometimes it does. And on the other hand, you know, look at the equipment in your transmitter site. Probably none of it has any kind of ETL or UL sticker on it. UL and all that
insurance sometimes.
Yeah. Well, and these things, of course, they're fused. You know, if something goes wrong and they short, it's just going to pop the fuse. Yeah, the insurance is they don't understand all the details of this sort of thing. So yeah, that sometimes is an issue, but overall, it hasn't been. There's not enough of it for us to shell out the $50,000 or $60,000 that it takes to get one of these things tested. It's insanely expensive. If you're General Electric and you're making 50,000 toasters a year and 1 million TVs a year or whatever, you know, UL and all that stuff is intended for consumer products where manufacturers in the past have been known to kind of cut corners at the expense of safety. But, you know, us folks that make commercial equipment that's intended for continuous commercial service, we know how to make stuff that's not going to burn your house down. So anyway, it's a little bit up in the air. We may do that. It depends on how much need there really is. So far, there hasn't really been any, but we'll see.
Again, I suppose it varies by jurisdiction. It's been too many years since I've been in LA, but seems to me that California or LA have some rules that sometimes you have to have stuff like this that.
Yeah, you know, but on the other hand, we got dozens of these things installed in Los Angeles. So
good.
Who knows?
Let's approach this question then. Is there monitoring? What monitoring is there? Can you see the levels? Do you see a history of peaks? Do you see the waveform?
Oh, you mean on the Powerclamp stuff?
Yes.
No, that would be done. To do that the right way, you need a power line monitor system, which is a whole different product. The Powerclamp, the only monitoring is if you want the remote status option, which is just a relay closure that gives you a contact closure if one of the units fuse blows. Like if the Powerclamp overloads for some reason, it'll blow its own internal fuse. And if you want to know that, if you want to be aware of a fuse needing to be replaced, that remote status option will do that. It'll just give you a contact closure. You can interface that to your transmitter remote control. But as far as monitoring the spikes and surges and voltage and noise on the line and all that kind of thing, you can get a power line monitoring system. There's companies that make those things. They're very sophisticated. They ain't cheap. Several $1,000s from what I hear. I think you can rent them if you think you have an issue. But no, we don't do that in the Powerclamp because that's a whole separate product.
I understand. I'm just exploring if someone wanted to know how bad their power was and how bad or how good it was after the Powerclamp.
Yeah, well, then, yeah, you can rent a power line monitoring thing, you know, rent it for a couple of weeks before you install a Powerclamp and keep it on the line for a couple of weeks after and see what you see.
Okay.
But yeah, they'll record, you know, voltage and spikes and all that kind of thing and monitor the frequency and so forth. And then you can download the data and take a look at everything.
Sure. Anyone else have a question that they'd like to pose to Hank on the Powerclamp or on the power monitor, the tracker?
Ken.
On your monitor unit, the little jumpers you have in there to select the phase and whatever, are those solder in or just clamp or just plug in?
Soldered.
You don't have to take the board out to do it, do you?
No, there's just little holes on the PC board and you move the jumper over. Yeah.
All right. Anyone else have a power related question?
On the monitoring box, the green connector that's for the remote control connections, it appears that you have to take the board out to make those connections.
No, that green thing unplugs.
Oh, okay.
Yeah. So you just stick your wires in it. It's a Phoenix connector, so you don't need to solder it. So you put the wires in the connector, screw them down, plug it back in, and away you go.
Sounds good.
All right. Very good. Any other questions? I think it's amazing when you think about what can come out of the power, and people don't think of it. But as you pointed out, there's all sorts of local things that can create a problem. Bryce sends us a note here that he's worked with his utility company to monitor power at transmitter site. They put the utility company put a recorder online.
I did that too in Hobbs, New Mexico, and they monitored it for several weeks and they came out and adjusted. I had low voltage on a couple of phases, but the trick is if you were to put in one of Hank's devices, they're not going to come back and monitor again to see how much it improved.
Well, yeah, probably not. Richard Rudman, he has two different power quality monitoring systems. Richard, you bring them out, you'll test people's feeds.
I have done that for my clients and also work with some people here locally in Santa Paula and Ventura County. I've worked with some farmers on some issues, and the equipment I have does do recording, but it's an interesting field because there's a whole terminology set of parameters that I had never heard of before I got into this, because you're talking about swells and dips and all sorts of other fun little words that have meaning in the power quality industry.
I don't want to put you on the spot necessarily, but have you monitored one of Hank's boxes? You're muted. Richard, you need to unmute yourself.
Yeah, I don't think I'd find very much to monitor at the output of it if it's doing its job, which evidently from Hank's track record that he talked about, it does. So I have one transmitter site in an oil field here in Santa Paula, and know well what Hank is talking about. I do have a different flavor of surge suppression that so far worked pretty well. But one thing it doesn't protect me against is the breaker out at the Edison pole a half mile down the road. So I just had to replace that after 10 years. It started to come up with some of these oil field trips that Hank was talking about.
Okay.
I once had a UPS that was reporting an event, and nothing was happening that I could see. It was the same time event. And so I turned that over to the power company, and they put their stuff on the line, and they traced that to a bump that was being caused by capacitor switching as businesses came offline in the end of the day. They were creating enough of a bump that the UPS could see it, but it didn't affect anything. Of course, that's why we have UPSs.
Yeah, and I suppose we should have a week where we discuss UPSs and what you should buy and what you should avoid, because there are a lot of them out there that don't know what a sine wave is on the output.
Hank,
Mhm.
your power tracker, is the output of that tracker for the remote control, it's a linear expression of the mains power coming into it?
Right. It just creates a DC output that's proportionate to what's coming in.
So you can see brownouts and things like that.
Yeah.
All right. Hank, I understand that you have a new version of the Talent Pro.
Oh, yes. Oh, you know what?
What?
I'll have to go get one.
Oh,
Hang
well,
on. I forgot about that. I'll be back. Let me run out to the massive warehouse. I'll be back in like 10 seconds. Yeah, we came out with a new version of the Talent Pod. There we go.
all
This
right.
is, you know, I could get a better picture and share it with you. It looks exactly like the original version. This is something you use in a studio, or if you're doing sports remotes. Gives you the ability to turn the mic on and off. It's got a cough button. And then the cool aspect is the headphone monitoring. There are two separate inputs for headphone audio, and you can mix them. We call one of them is local and the other is return. They can be anything. Typically one is program and one is IFB. And you plug them in to the back here. These are the two headphone input jacks. And the thing that we changed on this, which is invisible, is over here we have mic in and mic out. Well, the original version of this product used very simple passive mic on-off switching, where the buttons on the front simply shorted pins 2 and 3 of the XLR. Which worked okay, but it wasn't great. So what we did in this new version, which is called Talent Pod 2, is there is now an active mic preamp in here, and the mic on-off switching is done electronically, so it's dead silent without any clicks or pops, even if you're using powered condenser mics. Oh, there we go. Perfect. Yeah, the mic out is now balanced line level, or it can be mic level if you need that. But it has an active mic preamp, so there's no more clicks and pops when you turn the mics on and off. And you also see here 2 RJ45s. That's for linking multiple talent pods together. So if you're doing a sports remote with 2 or 3 people calling the game, your headphone audio and power will be looped through to all units. So you don't need a separate power supply for each unit. You don't need a DA for the headphone audio and all that kind of thing. So it makes the installation really simple. The other thing we did, and I'll have to, let's see, I'll have to pull up a, oops. Yeah, there we go. There's the front. So the mic on off button and cough, those are controlled with electronic muting. So it's a nice clean on off thing. And I can show you the new desk stand. But I think to do that, did I send you that picture, Barry?
No, I just pulled your
Oh,
website
okay,
up.
that's the spec sheet. Okay, yeah. If you unshare,
Oh, okay.
there we go. Okay, that's the spec sheet. There we go. All right, now I can go to my screen and find a picture of the new desk stand. This will just take a second. 59, 50. Oops, that's the old one. Yep, hold on. Okay, photos. Where is it? Oh, there we go. Okay, so there's the new retractable desk stand. And so that bail that you see at the front here, that thing folds flat. So when you need to move this, move the unit around or pack it to take it back to the studio or whatever, that just flips down. And it's a little easier to transport and store. compared to the old one. This shows it installed on a sports pod, but it works on either the sports pod or the talent pod. The difference between, excuse me, main difference between sports pod and talent pod is sports pod has talkback as a separate output for intercom / talkback, and it can be integrated with our sportscaster system to provide duplex intercom between the producer and the talent and all that other complicated intercom stuff. The talent pod does not have the talkback function. Otherwise, the two products are virtually identical. So that's the new bale that we have available for the sports pod and the talent pod 2. I'll very quickly just show you a couple of other newish things. This is a headphone listening station that we use for mostly used in a studio. Let's see if I can give you a better picture here.
What does that cost?
This, whoops, okay, hang on just one second. This is, let me take a quick look, Guest Pod 2, 230. This is, it's a headphone amplifier with these 2 extra buttons over here that are typically used for talkback, cough button, or whatever. And on the back, we've got 3 RJ45s. 2 of them are for audio in and out. So you can feed your left and right balanced audio into the 1/4-inch jacks here. And then if you're using a whole bunch of these things, you know, like around a conference table, you just daisy chain them with the RJ45s, and power and audio will be looped through to all units. There we go. Now you see there's one over here that's called control. Okay, that is for interfacing with the 2 push buttons in the front. Because everybody asks me, are the buttons compatible with fill in the blank? Yeah, there we go. Talk back and cough. So, okay, Barry, if you unshare, I'll show a close-up of what's inside this thing. There we go. And since everybody's wiring could be different, because there's not a real standard for how do you wire to cough buttons or talkback buttons and whatever. What we did is on the PC board, which is right here, you'll see a row of 8 holes immediately behind where the buttons are. So those 8 holes correspond to the 8 conductors of the RJ45, and you can wire the buttons to whatever pinout you need on the RJ45. So in that way, it will work with anything and anybody's wiring standard. The cool thing about this is that it comes in 2 flavors. This is the way we normally ship it. It's a, you know, nice plastic box that you can sit on a tabletop, or you can stick it to the underside of a counter. But we also sell a mounting plate that you can install in cabinetry. So that's another way that these units can be installed. So this is just, you know, it's a simple stereo headphone amp with a couple of buttons and the ability to daisy chain a whole bunch of them together using simple Cat5 wiring. Any questions on that? And I have one more quick thing I'll tell you about, and then I'll let you guys eat. It's a headphone amp. Pretty simple, right? Okay. And this is another, not quite new, but it hasn't been out too long. This is a digital DA for AES digital audio. It's the simplest thing in the world. On the back, we have a female XLR. You plug your AES audio into that, and then you see 4 male XLRs. So this gives you 4 clones of whatever you feed into it. And it also has over here on the side a SPDIF input. So if you have a SPDIF source, it will upconvert it to AES. Now, this is truly a distribution amplifier. All it does is it takes the AES signal and treats it like wideband analog. It doesn't reclock it or change the sample rate or anything. It simply takes whatever you feed in, and using very wideband analog circuitry gives you 4 individually transformer isolated AES outputs. So there is 0 delay. Nothing is being reclocked. So there's no timing issues. The input to output delay is measured in picoseconds. It's so slow, so short. It's just the amount of time it takes for the electrons to go in and come right back out. So if you need to take AES or SPDIF and split it into up to 4 places without introducing any delay or latency, this thing will do it.
Okay.
So there you go. That's what's new and what's sort of new.
Very good. Thank you, Hank. Any questions before Hank runs away and gets
Hey,
back?
Hank, I got a quick question on that AES distribution amp. Looks to me, the way you described that, you could also run analog audio through it.
Well, not quite, because the digital audio transformers, they're about this big. So the bandwidth goes way, way up, but doesn't go down.
Doesn't go down. Oh,
Doesn't go
okay.
down. I've never tried to see what the minimum frequency you can squeeze through there, but it's probably, I would take a guess, probably a couple of 100 hertz. So I don't know how good it would sound if you did that. You could try it, I suppose, but it's intended for square waves.
So it wouldn't pass video.
No, not analog video. No, because again, you need to have response down to almost DC to keep the tilt in control.
I saw Steve's hand a minute ago and then it went away. I don't know if Steve had a question or not. Okay.
He's waving.
Yeah. You had put your little reaction hand up, so that's why I saw. Okay. Hank, we really appreciate the information about the power clamps and the other products. They certainly should help a few sites.
Thank you. Thanks for this chance, for this opportunity. I hope everybody is staying healthy and has survived this whole COVID mess. And hopefully things are going to be, trending upward from here on out. It's been a challenge as a manufacturer, getting parts and components. And the weird thing was, the more common things are the ones that were the worst as far as getting delivery of stuff. The thing that we had the hardest time getting, power cords. Believe it or not, stuff that's on the shelf, you can get in, order it today at 500 power cords, no problem. Order them today, you get them tomorrow. Not for the last year or so. It's been weeks for some stuff. Luckily, we don't use microprocessors in any of our stuff. It's mostly, analog parts and through-hole parts, which there's not as much demand on those as surface mount. So we didn't run into too many problems, but the problems we ran into, we never would have guessed. Now the thing that's hard to get, cardboard boxes, believe it or not. The shipping cartons that we use, you know, big box about this big. Used to be able to get them next day. Now they're back ordered for weeks, but we'll figure it out one way or the other.
Should I try to sell you my box of 50 power cords?
Yeah. Yeah, it's crazy, but I think it is getting better. It's interesting. We're here right on the coast, and last fall, I could see 40 or 50 container ships just parked out there because of the backup at the port. Now you go down there and you only see a couple. You think, oh, great, everything is back to normal, everything is fine. Well, no, what they did is they moved all the ships about 25 miles off the coast. They're still there, all backed up. You just can't see them. We came back from a trip a few months ago. Oh, we were in Hawaii. So as we were flying back to LA, we circled over the ocean to, you know, get in the queue to land at LAX. Well, we were circling right over the area where all these ships were. And they're 20, 30 miles off the coast, dozens of them. It must have been 100 ships out there. So things are still backed up. But I think it's slowly getting better. It's not back to normal yet, but maybe 6, 8 months from now, it will be. We'll see.
Did they move them out to make the view prettier?
Yeah, they move them out so people wouldn't know how bad things were. Really.
Can't you just get your own little boat and go out there and get your parts?
That's kind of what I was thinking.
Well, I
I
thought
don't think they'd let me do that.
they were moved out there for an air quality issue because all those ships, you know, were running generators and stuff to stay alive. And,
Oh, yeah.
polluting the air when they were close into shore. So I think that was an air quality thing.
Yeah, that's probably another good reason why they did it. Yeah. Yeah, we will never know.
Well, Hank, we invite you back and look forward to seeing some more things that you've come up with.
Okay, I'll do my best. See what I can come up with. And one last thing, I'd like to announce that this year, believe it or not, is the 40th anniversary of Henry Engineering. 40 years since the first product, the first product was actually those little retrofit plug-in amplifier things for Autogram consoles. That was actually our first product in '82. And then the Matchbox came about a year later. So there we go. That one's practically an antique.
You're still around, but Autogram, I don't think is.
No. But
It was bought by Orban at one point.
yeah. I don't know what happened to them after that. That was kind of a strange purchase, but whatever.
Is Ernie Ankley still alive?
I don't know. I haven't talked to him in years.
I haven't either.
Yeah, I don't know. Huh. And
He
we'll
and
see
his
what
wife-
happens at NAB this year. You know, if I guess they're still having it. You know, I haven't heard anything to the contrary. So
Yeah, just got an email this morning from Nautel that they're going to have a larger than usual booth in the West Wing, and invite everybody to come visit there and get on the Tesla ramp thing, the shuttle.
Yeah. Okay. Well, I plan to be there. I'll probably be in. I won't have my own booth anymore. I gave up on that. But I'll probably be in one of the dealers' booth, maybe BGS. So if you guys are going, stop by and that's probably where I'll be.
I think you were there last time I saw you.
Yeah, at BGS. Yeah. The cost of exhibit space, you know, goes up every year, and the radio engineering attendance drops every year. So it got to the point where it just wasn't worth the money. So, but if I hang out at BGS or BSW or somebody, I can see a bunch of people and it's really easy. So,
Most people don't really know how much the NAP charges for a square foot. Plus you
Yeah.
have to rent the table, plus you
Oh,
have to rent the chair, and
yeah.
the carpet.
And it's all
Electricity.
union.
Oh, yes, it definitely is. It's, I used to, I had the smallest booth I could have, 10 by 10. And by the time you add everything all together, you can't get out of there for less than 10,000 bucks. And it's more now. So,
Some of
This
the
is
bigger
why-
companies, the transmitter guys are spending $500,000.
oh, yeah, not surprising. Yeah. But you'll notice that there are not nearly as many radio equipment manufacturers at the show today as there were 10 years ago. I mean, it
No.
used to be in almost the whole North Hall.
Mhm.
Now it's maybe a fifth of that, if that, so,
And worse,
All
they're spread around.
drones and HDTV.
yeah. Well, that's where the money is, so it's the way it goes. But anyway, I'll be there. I hope to see you guys. And I need to scoot, so I'll get out of here. And unless anybody has any other questions, I'll let you guys continue the meeting and have some pizza at home or whatever.
Thanks. Take care.
Okay. Thanks very much, guys.